You've learned your 5 types of reactions, and it is time to practice what you have learned. So the first reaction we're going to deal with is sodium oxide plus water yields sodium hydroxide. What kind of reaction is this? Well, you see that you have 2 reactants, but you only have 1 product. So if you only have 1 product, then this is going to be a decomposition reaction. Yeah, I think I've included this reaction probably 6 times on my notes so far, but you know, whatever, go with it. Zinc plus hydrochloric acid yields zinc chloride plus hydrogen gas. We have an element plus a compound. That's as far as you should have to go in knowing that this is a single replacement. And to specify whether it's cation or anion, look at what is the single guy in the beginning. Zinc is a metal, which means that when it bonds, it will be a cation with +2 charge, and so this is a cationic single replacement. Next one, we have calcium plus water yields calcium hydroxide plus hydrogen gas again. And looking at this, you see you have element plus compound. So again, stop right there. You have a single replacement. Anytime you have element plus compound, that is a single replacement. To determine whether it's cation or anion single replacement, look at the single guy. Calcium is a metal, which means that when calcium bonds, it will be a +2 charge again. I didn't mean to pick 2 +2s, but that's just coincidence. So this is going to be a cationic single replacement because calcium will form a cation. And a couple of you might be looking at this and going, whoa, wait a minute, why does the water, you know, where does this hydroxide come from? Well, you have to think of water in a different way than just H2O, and think of it actually as a hydrogen bonded to a hydroxide, and you can see H2O. And then from here you can see, okay, well here's the cation, hydrogen forms a +1 charge, and here's the anion, HOH. The OH is the anion, the hydroxide anion, and so calcium is actually going to take the place of the hydrogen, and the hydrogen is going to bubble off in the form of a gas. And so that's where the hydroxide comes from, right there. Then we've got hydrogen peroxide yields oxygen gas plus water, and you see that we only have 1 reactant, which immediately you should know that this is a decomposition. This is a great reaction that if you add a little bit of soap to this reaction, you get lots and lots of bubbles. Elephant toothpaste, look that up. Here we have copper plus silver nitrate yields silver plus copper 2 nitrate. The copper turned into a +2 charge. And so we have element plus compound gives us single replacement. Now look at the element that's going to be doing the swapping, and copper is a metal, which means that it is going to be a cationic single replacement, and copper is going to take the place of the other metal. Remember, whenever you're doing a replacement, you swap the similar elements. Here we have ethene. No, you don't have to know the name of this. C2H4 plus oxygen yields carbon dioxide and water. And if you remember, I told you, anytime you have something reacting with oxygen, you have a combustion reaction. Zinc oxide plus carbon yields zinc plus carbon dioxide. So you have compound plus element. So right there you know that it is a single replacement. And looking at the carbon, kind of look at the products and go, okay, what did it take the place of? Well, carbon's now bonded to oxygen, which means that carbon took the place of zinc. Zinc is a cation, carbon over here is a cation. So this is, again, a cationic single replacement. A little bit more, just because, you know, we can practice this much if we want. Sodium oxide plus carbon dioxide plus water yields sodium hydrogen carbonate, also known as baking soda. So looking at this, we've got a whole bunch of reactants, but we only have 1 product. And when you only have 1 product, well, then that's a synthesis. Here we have the same reaction I had earlier, so I don't need to do that one again. Potassium chlorate yields potassium chloride plus oxygen. This is the reaction that makes the screaming gummy bear possible. And you can see that you only have 1 reactant, so that right there tells you that you have a decomposition reaction. Here we have sulfuric acid plus barium chloride yields hydrochloric acid and barium sulfate. And this is an S right here showing that the barium sulfate is a precipitate. So looking at this, we have compound plus a compound. That means that it is double replacement. And over here, you can see that the hydrogen and barium have switched places. Or, don't do both switch places because then you just end up right back where you started. Or you can swap the anions. Totally up to you. Okay, so some other special types of reactions that you will encounter if you go on to a higher level chemistry, or if you just, for whatever reason, decide that you want to watch the AP predicting products video. Double replacement reactions are further classified as either a precipitation reaction, and no, again, I'm not talking about rain, or an acid-base neutralization reaction. Synthesis, decomps, and single replacement reactions almost always involve some kind of change in the oxidation numbers of the elements, and so they're actually called an oxidation reduction reaction or redox. And if you take AP Chemistry, you'll learn all about these. So you guys have a great day, and I will see you soon.